Today we are in section 10.4, surface areas and volumes of similar solids. Before we get started, this is the first video that I did not have archived, so it's not a live class that I'm teaching it to. This is current day, so today I'm recording this on March 16th. You're probably not going to watch it until sometime next week, but my prayers are with you guys, and I love you guys, and I am going to be here to make sure that we get this class finished. Speaking of finishing, section 10.4 is officially the last lesson of the textbook. Before you get too excited, we do have some other things we need to cover to make sure you're ready for Algebra 1. So, but that format might change a little bit. I'm still working on what I'm going to do with that. So anyway, you might need to pause a little bit more. I'll tell you kind of when to pause the video so you can work out some of these problems. But it's going to sound different because I'm sitting in my office. All right, so here we go. Okay, in example 1, we're finding similar solids, and you're going to notice a similar topic that I keep bringing up, and that is that we have to put this information, okay, so we see 3 cylinders here, A, B, and C. We need to put these into ratios so we can compare them. The value of the ratio will tell us which one is similar. So here we go. Because I'm comparing both cylinder B and C to cylinder A, I have 2 scenarios that I'm looking at. The first one is I'm going to compare cylinder A to cylinder B. All right, and the way I want to do that, and you'll understand why when we get to example 3, but I want to put, and again, there are many ways that I could set up this proportion, but if you do it this way, it'll make it easier for us as we get through all 4 examples. I'm going to choose to start with the height of cylinder A, which is 4 meters, okay? And I'm going to go height over the height of cylinder B, 4 over 3, equals the radius of cylinder A, 6, over the radius of cylinder B, which is 5. Okay, so I went height of A over height of B equals radius of A over radius of B. All right, and I'm looking for these ratios to be the same. Well, clearly 4/3 does not equal 6/5. So this is not proportional. Okay? Not proportional. All right, we'll just kind of abbreviate proportional. All right, so A and B are out. Let's compare A and C. And again, I could start with radius over radius. I could start with height over height. All right, as long as it's the same both ways. So let's just keep it consistent, and we'll go height of A over height of C. Okay, so that's going to be 4/5 equals radius over radius, which is 6 over 7.5. Okay, and before we say, oh, this is not equal either, this actually needs to be reduced, okay? And the way I could reduce it is to reduce it by 1.5. Okay, so basically you just want to make sure that this fraction is all the way reduced. And it can be reduced by 1.5. You say, man, I'm not sure if I could have got that. Well, even if you reduce it by half, you'll be able to see that you could reduce it again after that. So when you reduce 6 divided by 1.5, you get 4. And 7 divided by 1.5, you get 5. And so we can see that 4/5 equals 4/5. So yes, A and C are proportional. Okay, so that's how we're going to prove it. And we're going to do that on all of the examples in this lesson, where we're going to put the dimensions into ratios and we're going to compare them or use them to find unknown dimensions. So that's actually what we're going to do in example 2, is we're going to put this into a proportion and then just do cross multiplication to solve it. So again, we want to just make sure that in the first ratio, if we want to use the radius, we go the same direction from x to y or from y to x. I just kind of think that left to right is forward, so we're going to do it that way. So we'll put 5/7 into a ratio. And again, we did that because 5 is the radius of x and 7 is the radius of y. Equals, so because I went from left to right, I'm going to do the same thing with the slant height. This little L right here just means slant height, and it's slant height because obviously it's not a straight dimension. So equals 13/L, and then I'm going to cross multiply 5 times L and 13 times 7, and I get 5L equals 91. Divide both sides by 5, and L equals 18.2 yards. All right, and that's how you would find slant height. All right, now obviously we're not going to pair together on this, but this is just a different way of looking at finding or solving for an unknown dimension. So we're actually going to do this twice. So this is going to give you some practice. This is where I would want you to try to pause it and work the problem out yourself, and then play the video and see how you're doing. So it says that these prisms are similar. So because they're similar, you can set up ratios where you're comparing their dimensions. For example, you need a ratio where you know both dimensions. You can only solve for one variable at a time. So that's going to be the height. Now you know the length of the big one, but you don't know the length of the little one. So we're just going to put that into a proportion. And again, it doesn't matter which way. So what I mean by that is you could put 20/8 first, or you could put 11/L first. So I'm just going to start with 11/L, L for length, equals, and again, you have to go big to small because I went big to small in the first one, 20/8. All right, now we can do our cross products. 11 times 8 is 88, and 20 times L is 20L. Divide both sides by 20, and L equals 4.4 inches. Okay, all right, so I want you to take a minute and pause it. See if you can set up the proportion to solve for W. Obviously, you're not going to be using 11 anymore because you already solved for length. All right, you'll still be using the height ratio, 20 and 8. But see if you can set up your proportion, use your cross products, and solve for W. Okay, so the way I set this one up is I did 8/W equals 20/8. And I got 20W equals 64. Divide both sides by 20. And W equals 3.2 inches. All right, so solving for an unknown dimension. That's how I would do that. And now we're going to, we'll skip the additional problem for now because it's pretty much the same as the one we just did. We're going to dip into now surface area. Okay, so before we were just comparing these solids and we were saying, okay, what's the unknown dimension? Well, now we're doing that, but the surface area is involved. So we have a different formula here. We have a formula to follow. We're going to put the surface areas of the figures into a ratio. And we're going to compare it to a ratio of their dimensions. But then we got this little 2 up here. You guys remember what that means? That means that I have to square that ratio. All right, so let's see what this looks like in a problem. Okay, so it says that the pyramids are similar. Because they're similar, I can put them into a proportion. So I'm just going to go top to bottom, A to B. Again, this could work if you go B to A. All right, so there's multiple ways that you could set this up. But just to kind of keep this as simple as we can, let's go from A to B. So what we would do is we're going to start with our ratio of the heights of the pyramids. Well, it really doesn't matter. Let's start with surface area since that's the way they set it up here. All right, so surface area of of A is what I don't know. All they give me is these dimensions right here. The surface area of B, however, they do give me. Okay, so I'm going to put that into this ratio. I don't know the surface area of A, so I'm going to do S for that. But I know the surface area of B is 600. And now I'm going to do the height of my pyramids, which is 6 over 10. Okay, and again, I'm going A to B. But my formula says I have to take that ratio and I have to square it. So now it's going to be S over 600 equals 36 over 100. When I do my cross multiplication, I get 216,000 equals 100s. All right, so I just did my cross multiplication. Now to solve for s, you could probably guess, divide by 100. Oh, sorry, I put one too many zeros. It should have just been, and if you did that math, you were probably thinking, I did that math wrong. Okay, there should have only been 2 zeros here, 21,600, all right? Sorry about that. So then when I divide by 100, I just knock off these N2 zeros. All right, divide by 100 means move my decimal left 2 places. You could use your calculator for that too, so that would be fine. And 216 feet squared is the surface area. You could say SA, all right, for pyramid A. And we don't have to get too specific on all of these labels, but we're just writing that out so we can really clearly say this is the surface area for pyramid A. And we can do all this using proportions, just like we did here. Okay, so now the last example is basically the same thing that we've been doing, except now it's volume. So remember, volume is the amount that it would take to fill an object. Okay, so we're going to say volume of the figures equals the ratio of whatever dimension they give me, but then I have a 3 up here. So if you guys remember, that 3 means to raise it to the 3rd power, which is that number multiplied by itself 3 times. All right, so let's see what this looks like. It says that they're similar, so that means I can use a proportion. The volume of A, which again I don't know. Okay, so we're just going to say V for volume, over the volume of B, which is 288, equals I'm going to put the height again into a ratio, 5/12, but now I need to cube it. All right, so V/288 equals 125 over 1728. And remember, I got this number because I did 12 times 12 times 12. 12 to the third power. Okay, so do my cross products again. And I get 1728. V equals 125 times 288. Hopefully you have your calculators handy. Times 36,000. All right, and now you guessed it, we're going to divide by 1728, both sides. And we've got a repeating decimal, that's okay. Volume equals 20.83 repeating, centimeters cubed. All right. Oh, it says round your answer to the nearest tenth. I thought it was might call for rounding, and the directions will say that pretty clearly if you need to round or not. And the reason they did that is because we had that repeating decimal. So if it says to round to the nearest tenth, what would the 3 do to the 8? So if you say that it drops off, you're correct. All right, so we did that because the instructions clearly said to round. But if we want to be exactly correct, that means we need to approximate our answer now because we rounded. All right, so it makes me a little sad to say, but that would be it. Everything you need to know for section 10.4. So, you know, again, I'm sad that I couldn't teach you this lesson in person, but I think we'll be able to work together to make sure you still learn everything you need to know to get you guys ready for next year. And I'm sure I've been, at this point when you're watching this lesson, emailing you guys and letting you know what we need to do as far as getting these assignments done. But you can reach out to me, email, remind, and I'm here to help you guys. So that'll be it for section 10.4.